Okay, so yeah, I'm going to go ahead and get the recording started now. So, and just so this is on the recording, I'll say it again. But yeah, next week, we just have a test. It's going to be on Friday. You can start it. You can take all day to do it. You have to turn it in by 3 on Friday. But like I said, I'll get it posted as early as I can, maybe 6 a.m., 7 a.m. Just so to make sure for those of you who like to get up early that you'll have plenty of time to get the test done. Just make sure you don't save a bunch of other stuff to do on Friday for other classes too, because this, the test needs to get done. So, but that's the only thing you'll have to do next week. I will probably post something else, something to just keep you sharp, and maybe like a couple puzzle worksheets if you want to try and do them for a couple points of extra credit on the test. But the only thing you'll have to do next week is just take that test. Okay. So,
Emma, look at my duck.
Okay, before we get started, everybody look at Haley's ducks. Baby ducks.
I got 6 of them.
They're not rubber. They're real ducks.
Real ducks. Emma, they follow me around. It's the funniest thing ever.
You can still, yeah, they still float in the bathtub, but they are real.
Okay, let's
All right. Hi, Jenna. Wow. Is that a real background?
No.
Oh, too bad.
It looks real.
Yeah, it does. It did for a second. Okay, so who wants to talk about math?
Me.
All right. Where do you want to start?
Number 30. Wait, just a second.
I'm going to bring it up here on my iPad, and then we'll all be able to see my screen, and we can take a look at
32.
You want to go right to the last problem, huh?
Yeah, I really need help with the last page.
Okay.
Me too.
No worries. This is now this is, so it's kind of hard to decipher, but I did give you all the information you need in here. So let's just read through it. We'll kind of talk about it, and feel free to, either raise a hand. Now, I wonder if I can get everybody. It doesn't really. Let's see if I'm trying to adjust this here. If I can get everybody in. Okay, well, that might work. Okay, I just want to make sure. All right, well, good enough. Okay, that'll have to be good enough. All right, number 32. A clothing manufacturer wants to produce denim jeans and denim jackets. Each pair of jeans requires 2 yards of denim and takes 0.25 hours to make. Each jacket requires 3 yards of denim and takes 0.5 hours to make. The manufacturer has 900 yards of denim and 120 hours to spend making jeans and jackets. Okay, so basically what they've given us here, we're talking about a company, and they have a couple restraints, okay? Just like if you remember the problem we did about the toys with the toy cars and toy trucks with the wheels and the seats, right? They could only produce enough, cars and trucks until they ran out of seats or they ran out of wheels. Either one. If they run out of either one, they can't make any more toys. So the same thing here. We have 2 constraints. We have 2 limitations that this clothing manufacturer has to think about, okay? We only have 900 yards of denim, so we can only make so many jeans and jackets. And we also only have 120 hours to maybe pay the labor force to make this stuff. Okay, so basically, I've given you the inequalities here. You don't even have to come up with the inequalities on your own, and I've defined your variables for you. So right here, X is the number of pairs of jeans, Y is the number of pairs of jackets. And obviously, that's what we're trying to figure out. How many pairs of jeans and how many pairs of jackets can this manufacturer make while still staying within the bounds of their restraints, okay? So this first inequality means what does this have to do with? Does this have to do with the fabric limitation or the hours? the key here is 900. Where does that 900 come from?
The yards of denim.
Okay, so 900 corresponds to the yards of denim. So this must mean that, let's see. So yeah, each pair of jeans requires 2 yards of denim, and each jacket requires 3 yards of denim. So that's where these expressions come from. So basically, we could say here, remember, so what would be a good way to say this? So what it's really saying is 2x is the total amount of denim that the pants would take to make. And 3y is the total amount of denim that it would take to make the jackets. And that has to be less than or equal to 900. So how about this? Amount of denim used must be less than or equal to 900 yards. That's really all that inequality is saying. Okay, it's a statement, but it's written in math, numbers, and symbols. All right, but that's what it's saying. It's saying if you take all the denim that is used to make all of the jeans and all the denim that's made to use all the jackets, it has to be less than or equal to 900. Okay, so if this one is about the denim, then what must this one be about? What's the other limitation that this company has?
The time? Wait, no.
Right. The workforce, the labor hours. Okay, so if it takes a quarter of an hour, so 15 minutes basically. It takes 15 minutes per pair of jeans, and it takes a half hour per pair of or per jacket, then that has to be less than or equal to 120 hours. So amount of time required to make products, that's not must
Is
be
what I
less than or equal to 120, not yards, hours. Got my labels wrong. Right?
is
Okay,
my
I guess I shouldn't put LPOET, you don't know what that means, but you can put this symbol, must be less than or equal to 120 hours. Okay, questions so far? Okay, good. So, and we're saying, yeah, this value, they both need to be less than. So when we graph these, and we are going to graph them here in a little bit, we're going to be using a solid boundary line, or we're going to be shading below. All right, so now, can anybody tell me what these last two inequalities represent? What do they mean? X is greater than 0 and Y is greater than or equal to 0.
Jeans are greater than or equal to 0?
Yeah, I mean, it just means you can't make a negative amount of jeans or jackets. Okay, it works the same thing for X and Y. They're just saying that X and Y have to be either 0 or positive numbers. It's impossible to make a negative amount of jeans and jackets. So that's all it's saying. Number of jeans can't be negative. And then same thing, number of jackets can't be negative. Okay, so now we know what all of these inequalities mean. We really have a system of 4 inequalities here, but 2 of them, I'm going to go ahead and graph these 2 right now. Remember, so basically, X is greater than or equal to 0. Here's the boundary line. And then we would shade everything to the right, because that's where X is greater than or equal to 0. Okay, and then we also have a boundary line right here. Okay, and that's these two. We're basically just saying we're cutting off those. We can't have negative values, so all of our values are going to be positive or 0. All right, so convert your inequalities to slope-intercept form and graph the system to find the solution. So basically, yeah, I'm going to take, do I have some room down here to work? Okay. So I'm going to take this, copy that, I'll bring it down here. Okay, so we need to solve this for y so we can graph it. All right, so we're going to subtract 2x from both sides. We get 3y is less than or equal to, I'm going to slide that negative 2x in front of the positive 900. So we have it in y equals mx plus b form. And then we divide everything by 3. So y is less than or equal to negative 2/3 x plus 300. All right, so let's go ahead and graph that. We are going to start at 300. And somebody tell me, do the scales on this coordinate plane, do the scales go the same? Are they equal scales for x and y?
Yeah.
Yeah, they all go by 50 each line. So that means we can use the slope technique that we always do. We can go down 2 units and right 3 units, because that's what a slope of negative 2/3 do for us. So we go down 2, right 3. That gives us that negative 2/3 slope, and then we just keep doing it until we run out of room. All right, and there we go. So draw our line in here. It's going to be a solid line. We already talked about this because of the inequality sign that's used, okay, less than or equal to. And then we're going to shade everything. So yeah, I'll do the other one in a different color. This one we'll do in red. Okay, so remember, we're shading everything above the boundary line for y is less than or greater than or equal to 0. We're shading everything to the right. Okay, so far this is where our solutions lie, but we have one more inequality to graph. Okay, so let's do that in blue. I'm going to copy this, bring it down here. All right, and let's solve this one the same way. So subtract the x term over to the other side. 0.5y is less than or equal to negative 0.25x plus 120. We divide by a half. Okay, so our answers are actually going to get bigger here. Y is less than or equal to, all right, so calculator 1/4. So well, actually, we're negative 1/4 times 2, so negative 0.5, I believe. Somebody check that. Is that right?
That's what. Oh, yeah, that's what I got.
Negative 0.5. Okay, just wanted to make sure I'm right.
I got 1/2.
Yeah, 1/2, right. Okay, that's what I was just going to talk about. Okay, so using a slope of 0.5 this is like the one time where we actually want a number to be a fraction, because then we can graph it a lot easier. So yeah, let's convert this to a fraction, and then that'll tell us what the rise is and what the run is, and that'll make it easier. So negative 1/2 x plus 240. All right. So we start at 240. Now we're just going to have to do our best to get these in the right spot, because it's not exactly on a grid line that we're used to, but 240 would be right about here. Okay, and then from that spot, this is a little tricky, but you should be able to stay with me if it makes sense to you. So from that spot, we're going to go down 1 full box, and then we're going to go right 2 boxes, because our slope is negative 1/2. So I'm going to go down to about 190, and then I'm going to go over 2 blocks and see. So all my points will be just a little bit below the horizontal grid line, because I'm going down 1, right 2. All right, so we just keep doing that. Okay, so now we're down at about 140 and 200, and then 90 and 300. Okay, and then 40 and 400. And then we would be down too low, so we can't, that one really doesn't make sense. That's not within our bounds. Okay, so let's see if these connect. Now, if if you're trying to connect them with a straight line in Notability and one of your points is just off by a little bit, you can move it. You may have, this is not going to be perfect by any stretch, but this is what we have now. So we can highlight this in blue, everything below. Remember, we're shading below the solid line because we're using a less than or equal to sign. So you see there's that little tiny wedge. This is going to take me forever. Okay, but it doesn't have to be perfect. I keep telling myself that, but then I try and make it perfect every time. Such is the life. All right. Okay, so this is our graph. So where are these solutions? Where are the amounts of jeans and jackets? Oh, there's one thing I didn't do yet before we answer that question. I didn't label my axes. So you definitely want to do that. If X represents the number of jeans that are produced, then you want to label that there. And then over here, number of jackets, or the Y-axis. Okay, so where are the solutions for the number of jeans and the number of jackets a company can make? Anybody?
Wait, what?
Where are the solutions? Where are the amounts of jeans and jackets that the company can actually make?
Oh,
Would this point right here, 100 jeans and 200 jackets, would the company be able to do that?
no.
No. That would satisfy the red inequality, but it would not satisfy the blue inequality.
The
Okay.
300 one.
What'd you say?
That one. That one. The 300 one.
Would this be possible for the company?
Yeah.
No.
No.
It doesn't. This is outside of the blue inequality. The blue inequality.
Oh.
Yeah, see that?
So
So,
the 450.
basically any point in here. Okay, and now do you see? I'm going to zoom way in on it. See how that they cross right here, and there's this tiny little sliver right here that's shaded in blue, but it's not shaded in red. Okay, that area would be off limits also. So even though it looks like a triangle, like this big purple triangle, it's actually a four-sided figure. So we go, here's one corner, here's one corner, here's one corner, and then the fourth corner would be right where they cross. So it is a four-sided figure. And anything inside this four-sided figure, this quadrilateral, that would be a solution. That's shaded twice, so that's where all our solutions would be. All right, so part C, it says list two possible numbers of jeans and jackets that the clothing manufacturer could produce. So somebody tell me one answer for this problem. And remember, there are literally hundreds that you could pick.
450.
450, well, I need an ordered pair. So I need an X and a Y.
450 and
So if X is 450, what does Y have to be within that quadrilateral where the solutions are? Whoops. Let's do that.
oh wait, hold on. Oh, hold on. I missed the
It could
point.
be an answer, but there's only one number you can give me that's going to work.
500.
No, 400, 450 and 500, that point would be way up here. Like it's even, so what's this point right here? This is the only point where X can be 450.
0.
0. 450 and 0. Meaning the company could produce 450 pairs of jeans and not make a single jacket. And that would work. That would fit within their constraints. Okay, somebody give me somebody other than Emma, somebody give me a different point that the company could possibly manufacture.
100, 150.
Right, 100, 150. That's right here. And that is within the blue area. Okay, somebody give me another one.
50, 100.
50, 100, right here. That is definitely something that the company can do. Okay, however, you can see if they make 450 pairs of jeans, they're making a lot more product. And so their profit might be higher. But like I said, any point that's in this purple four-sided figure right here would be something that the company could produce. All right, so if there is a problem like this on the test, it's going to be pretty much like this. It'll be a different situation. It'll be different context, but I will probably give you the inequalities, and I just want to see you graph them both and interpret what it means. That's really the important part. Okay. All right. What else?
29 and 30.
29 and 30. Okay. I like these applications because 29 kind of walks you through how to set up a system of equations, and then the next two, you have to use that same technique and set up the equations. Okay. So I am going to move kind of fast through this. So let's go ahead and get started. You have a money jar containing nickels and quarters worth $1.55. So you have monetarily in money, you have $1.55. The money jar contains 11 coins. How many of each coin do you have? Well, I gave you two pieces of information in this problem, and those two sentences are what you're going to use to write your two equations. Okay, so first we're going to have an equation that represents the number of coins we have. So basically, if we're going to define our variables here, what would be a good, so we have, let's see, the question asks us, how many of each coin do you have? So whatever they're asking us to find, that's going to be our variable. So what do you think, what would be some good variables to use in this problem?
I just use X and Y.
Okay, you use X and Y, but what do they represent?
Nickels and quarters.
Right, nickel. So let's pick, it doesn't really matter which is which. This is why we define it so we don't get confused. If you ever forget, oh crap, is X nickels or quarters? You can just look back up here what we wrote. All right, so X is nickels, Y is quarters. Oops, slide that R in there. Okay. So there are 11 coins in the jar. If we take the number of nickels and the number of quarters in the jar and add them up, we should get 11 because it says the jar only contains nickels and quarters. So there's no dimes, no pennies, no nothing else. All right, so the first equation is just X plus Y equals 11. However many nickels you have plus however many quarters you have has to equal the total number of coins you have. Then the second problem is going to represent the value of the coin, so how much they're worth. Okay, so what are we going to put in for, what are we going to multiply by 0.05 to find its value? Is it going to be X or Y?
X.
Yeah, it's going to be X. Which one of those coins has a value of 0.05? That's a nickel. That's 5 cents. So X goes there. You multiply its value times how many there are, and that gives you the total value of all the nickels. Do the same thing for the quarters. Okay, 0.25 times how many there are gives you how much money you have in quarters. So now we have our two equations. All right, so substitution would be easy to use here. Elimination would be easy to use. Let's see. What I'm going to do, I'm going to use substitution. I think it's just going to be easier here. So basically, I'm going to take this equation. We're going to solve it for Y. So if I subtract X from both sides, I'll just write it out. We don't have to go that fast. Okay, X plus Y equals 11. If we're going to solve this for a variable, I just chose to solve for Y. You don't have to, but that's what we're used to doing. So I figured, why not? Let's just do it. Okay, so Y equals 11 minus X. All right, I'm going to take that expression, plug it into the other equation for Y, and that's going to give me 0.05X plus 0.25 parentheses 11 minus X, and then that's equal to 155. Okay, did I lose anybody? Everybody understand that substitution step? If not, speak up. Okay. Okay, so let's keep going. Now we got a complex equation to solve here. Get my calculator out. All right, so we're going to distribute first. So 0.05x plus, let's see, 1/4 of 11 2.75, and then minus 0.25x equals 1.55. All right, so now we have some like terms we can combine here. So 0.05 minus 0.25 should be negative 0.2x plus 275 equals 155. Okay, now we got a two-step equation. So we're going to subtract 2.75 from both sides. Get negative 0.2x equals so that gives me negative 1.2. Let's take it up here. And we'll divide by 0.2, negative 0.2 on both sides. And we should get a positive answer. And that's going to be a 6. So what does that mean? Somebody tell me, in the context of the problem, what is that? What did we just do? X equals 6. What does that mean?
Oh, 6 nickels.
Perfect. So we have 6 nickels. If we have 6 nickels, how many coins or how many quarters have to be in that jar?
Mine
Look
was
right
wrong.
here.
Wait.
X plus Y equals 11. If X is 6, right, Y has to be 5. So we can go ahead, I'll do it the long way. We take X plus Y equals 11. We put a 6 in for X. And then we subtract 6 from both sides. We get Y equals 5. So good answer to this one. There are 6 nickels and 5 quarters in the jar. So there you go. And that's kind of how you want to approach all of these systems story problems. I give you 2 pieces of information that kind of are parallel to each other. Okay, those are the 2 things that you use to write the equation. So let's try number 30. All right, I'll read it and then we can break it down. Let's change up colors. Okay, it's time for an algebra party. Mr. Schaab goes out and buys 3 rolls of streamers and 15 party hats for $30. Mrs. Volk buys 2 rolls of streamers and 4 party hats for $11 at the same store. Find the cost of streamers and the cost of party hats by solving a system of linear equations. Okay, so first thing we do, we read what they're trying to get us to find, and then we define our variables based on that. So find the cost of streamers and cost of party hats. Let's say X is the cost of streamers, and Y is the cost of party hats. All right, so we know what. I'm sorry, go ahead.
I have to go because my brother's hungry.
That's okay. That's
Bye.
okay. See you later. You can watch the video.
Okay.
Okay. Okay, so now let's do some highlighting here. Okay, so they give us 1 piece of information here. Let's do, why not purple? And then they give us a second piece of information about streamers and party hats there. So, what equation can we write based on the sentence that I highlighted in red there about Mr. Schaab? Whoops, what did I do? Huh. Okay, anybody?
3x plus 15y equals 30.
You got it.
Oh, wait.
No, you're right. Oops, sorry with the wrong one. Okay, so 3 rolls of streamers means 3 times x, because x is the cost of the streamers. So 3x plus 15y equals, what was it, 30?
Yeah.
Okay. And then, of course, in purple, the other equation, we would set it up the same way. So 2 rolls of streamers would be 2x. 4 party hats would be 4y. And she spent $11. Okay. So I would want to use elimination here, but before we can do that, we need to have opposite coefficients, right? So let's see, what's the easiest way to get opposite? I really don't want to use substitution here because I know fractions are going to be involved. So let's see, what's the best way to get opposite coefficients here? What do you think? If we add these together right now, we're not going to get a 0. We're not going to eliminate one of the variables. So how can we change these equations to get opposite coefficients on one of our variables? This is really the key to understanding how to use elimination right here. This is the toughest part. What do you think? Lena, Dory, any ideas? What's a multiple? Okay, I'll make it easy on it. Let's focus on the x's. Okay, let's say we want to eliminate the x's. What's a common multiple of 2 and 3?
6.
6. So we can turn these both into 6s. We just got to make sure that we turn one of them into a positive 6 and we turn one of them into a negative 6. So how about we do this? I'm going to multiply the top equation by -2, and that's going to give me a -6x on top. And then I'm going to multiply the bottom equation by +3, and that'll give me a +6x. So I'll have a -6x and a +6x. Then the x's will cancel out. We can solve for the y's. All right, so let's rewrite them. So we get -6x. -2 times 15 is -30y. And -2 times 30 is -60. Okay. Second equation, we get a 6x. We get a +12y. And we get a +33. All right. So now we're ready to add these together. All right. The x's drop out. We get a 0 there. We get -18y. And we get, what would that be, 27, -27. Okay, and then we divide both sides by -18. And what's that, 150? Okay, you would get 3 halves if you simplified that fraction. So 3 divided by 2 is 1.5. All right, so what does that mean?
Hold on, I'm still writing.
That's okay. I got time. No worries.
Okay, what was the question?
Okay, so what does that mean? What does y equals 1.5 mean?
That the party hats cost $1.50.
Perfect. Yes. Okay. So all we have to do is find the cost of the streamers. Now that we know y, we can I'm just going to take this purple equation here, 2x plus 4 times 150. And again, you don't have to put the 0 there, but since we're talking about money, sometimes students like it a little bit better. It makes more sense. So 4 times 1.5 is 6. So 2x plus 6 equals 11. Subtract 6 from both sides. 2x equals 5. And then when we divide 5 by 2, we get 2.5. So party hats cost $150 and streamers cost $250. Okay. And of course, you can always check these answers. I know I don't do it a whole lot, but I like to say it a lot. You can plug in 150 for y and 250 for x and see if you get 30 when you simplify this. And if you do, you know you got it right. Okay, but typically when the numbers work out to nice, rounded numbers, like that, it usually means you did something. So. Okay, so I'd like you to try 31 on your own. Remember, just go through all the steps that I did here. Use the question that they ask you or what they tell you to find. Use that to define your variables. Excuse me. And then use the information they give you about the situations to write your two equations. And then once you have your two equations, it's just a practice problem from there. Okay, so how are we feeling about those? Pretty good. Good. Okay. Any other type of problem you wanted to go over?
Good. Can we do like?
So number two. Go ahead, Dory.
No, go ahead. You can talk.
Okay. Number two, like I was confused because I didn't get they weren't crossing for me.
Oh yeah, right.
The lines.
You're right. They're not crossing. So what does that mean?
It's no solution.
It's no solution. Yeah, let's go ahead and we can go ahead and graph. Okay. You can tell without even graphing that there's going to be no solution because we have the same slope, but we have different y-intercepts. So what that means is we're going to graph. If we graph this first one here, I'll do this in blue. We're going to start at -1, and then we're going to go down 3, right 2. So or we could go up 3 and left 2, up 3, left 2. All right, and so when we do, let's do the other one in red. So we have the same slope, so we're going to go down 3, right 2. It's always going to be parallel. So when we draw these in here, they're never going to cross. So yes, the answer here is no solution. Remember, that is possible. It's also possible to get infinitely many solutions. If I can change this, if I draw one line in this problem, okay, now they have infinitely many solutions because they are the exact same equation. They'd be lying right on top of each other. So they don't just intersect in one place, they intersect in every single place on that line. All right, but if we take that away, now the y-intercepts are different, so the lines are not in the same location on the y-axis, and therefore they're never going to cross. Okay, so that's one of our special cases. You got to always be looking out for those. All right, Dory, what did you want to ask about?
Could we do like one substitution problem and one?
Absolutely. Yeah, let's do. Let's see, which one looks kind of tough here. Actually, these are all kind of easy. Do you know how I know that, or why I would say that?
Why?
Why am I saying all 4 of these substitution problems are on the easy side?
I don't know.
Okay, well, great. Then it's a good thing we're talking about this. Look at when you're using substitution, the first thing you need to do is get a variable by itself in one of the equations. And you can see in all 4 of these problems, we already have a variable by itself here. We already have a variable by itself here. We already have a variable by itself here, and we already have a variable by itself here. So that makes it easier for us. We don't have to do any manipulating of these equations to get a variable by itself. So why don't we just do, this one looks kind of tough, so let's do 7 together. All right. So remember, let me get my highlighter out here. What I'm going to do is I'm going to take this -y equals 34. I like these red. And I'm going to plug that in for x in the other equation. So basically, we're going to use parentheses too. And so we're going to plug that expression in for x because it's equal to x. They are the same thing. X and -1y plus 34 are the exact same number. So we're going to replace x with that expression. So this becomes negative 22, and instead of x, I'm going to open parentheses, put that expression in, and close them. And then everything else just stays exactly the same in the rest of the equation. Okay, there's the substitution step. I substituted an expression that was equal for x in for x in the other equation. All right, so now we distribute. That's a positive 22y. Let's see, that's going to be a negative, whatever this huge number is. Get my calculator out. $748 plus 33y equals 132. Okay, they're big numbers, but who cares? We got calculators, right? We can do it. So let's combine like terms. Positive 22 and positive 33 is a positive 55y minus 748 equals 132. We add. Okay, this is just a two-step equation now, so hopefully you feel pretty confident from here. All right, 55y equals 880. Okay. Oh, somebody just come in? No, somebody left. Okay. All right, and then we divide that by 55, and we get 16. Look at that. Like I said, when it works out to be a whole number like that, even though you're using these big old numbers, you can probably assume that you did it right. Okay, so we're not done yet. Now we got to take that 16 and we got to plug it in for y in one of the equations. So I'm just going to use the bottom one. It's already solved for x, and that's what we need to find. So negative 16 plus 34. All right, all I did was put the 16 in for y. And now we simplify. So negative 16 plus 34 should be what, 18? All right, so there's our answer. 18 comma 16. Come on. All right. So does that help, Dory? You're muted right now. I don't know if you know that.
Me? Well,
Yeah. Does that make sense, or do you still not understand like the process?
oh, I understand it now.
Okay. Just it sometimes getting started is the hardest part. But like I said, in number 8, the easiest way to do this. Now, there are lots of complicated ways that you can solve it correctly, but we always want to find the easiest and best way. So in number 8, go ahead and substitute this expression into the second equation for x because it's equal, and that'll save you a lot of time and a lot of headaches. Okay. All right, Kate, how about you? Everything good for you?
Yeah.
Awesome.
Can we do an elimination?
All 3 of you have been turning in awesome work. It looks great. I can really tell that you are putting some time and effort into it, so I appreciate that. Dory, did you have another question?
Can we do like one elimination one?
Sure. We still got about 10 minutes here. So
Okay.
let me find a difficult one. Okay, so 9 and 10 are a little bit easier. Again, do you know why I say that? What makes 9 and 10
No.
easier? Somebody tell me.
They already have
Go ahead.
the variables?
Well,
Okay.
we're not looking at the variables. They all have variables, right? All of these problems have x's and y's. But what are we really looking for in elimination? What about this system tells me that it would be easy to use elimination? Anybody? It's the opposites.
Which one are we doing?
Well, I'm looking. I want you to look at all 4 of them really quick because I want you to understand
Okay.
why I call 9 and 10 easy and why I call 11 and 12 difficult. It's because of the opposite coefficients. You see right here we have negative 4x and positive 4x. That means we can add these two equations together and immediately the x's will drop out. We don't have to do any work to make that happen. Same thing with 10. We have opposites right here, negative 3x and positive 3x. So when we add them, we'll get 0x and the x will drop out. In 11, we don't have that. We don't have opposite coefficients. However, so let's do 11. We're going to do 11 together. However, what can I change? There's a way that I can multiply one equation by a number and get opposite coefficients. Actually, there's two ways we can do it. Somebody tell me one way that we could get opposite coefficients here.
You could do the -6 times, and like you could do -2 for that.
Well,
wait,
we
no.
don't want to multiply by -2 because that would give us a positive 12x, and we want them to be
So
opposite. So
then you want to do a +2.
right, very good. So we multiply by +2 on the bottom. That will give me a -12x. Then the x's will cancel. And the y's won't cancel, but we don't want them to. We want the y to stay in the equation so we can solve for it. So I'm going to rewrite both equations. It's always a good idea to do this. All right, don't get lazy. And then that gives me -12x. And of course, I have to remember distribute. So 2 times -1 is -2y. And 2 times -15 is -30. All right, that's the most common mistake students will make when they do these is they forget to multiply the constant on the other side of the equation by that 2. All right, so now we're ready to add them together. Eliminate the x's because we get a 0 there. We get 5y when we add the y terms, and we get -15. Okay, so we got a simple one-step equation here. We just need to solve for y, and we get y equals -3. And once you have that, all we got to do is plug that back into one of the equations for y, and then we can solve for x. So I'm going to use the bottom equation, -6x minus, and this is where you got to really be careful. And this is why I wanted to use the bottom equation so I could show you this. 80% of students are going to just put in -3 there. They're not going to put in -3, and then they're going to get the sign wrong. So be very, very careful when you substitute. Everything has to stay exactly the same, and you're using parentheses to put in that new number. All right, so let's finish this up here, -15. All right, so I see two negative signs together, so I'm going to add. So it's really like -6x plus 3 equals -15. Then we subtract 3 from both sides. -6x equals -18. And then we divide by -6. And we get x equals 3. So what's the solution? We would say that the solution is 3, -3. Okay, so in other words, if we put in a 3 for x and a -3 for y, both equations will come out true. All right, so sometimes in elimination, like in number 12, you're going to have to change these equations to get opposite coefficients. But don't remember, like right before we go, after everybody turns in their work in your class, then I will post the answer key for this review. So the very first thing you need to do next week is look at the answer key to this review and fix your mistakes and look and see if you're doing everything right, so on and so forth. And then you can kind of ask me for help if there's something on the answer key that you don't understand. Okay, so be looking for that. Like I said, if they're late assignments, then it might not be posted until Monday. But if everybody gets their stuff turned in, then I'll post the answer key maybe Friday, maybe Saturday.
I have a real quick question.
Yeah, sure.
Okay, so when we put the 2 by the -6, where did we get the 2 from? Like,
well, that's where you kind of have to use your brain and think. Like, it's a good question. So basically our goal, remember what our goal was, is to get opposite numbers in front of one of our variables?
yeah.
Yeah, okay. So multiplying this by 2, the reason we picked 2 is because we know that 6 is half of 12. So if we multiply 6 by 2, we'll get a 12 here for x. And we want this number to be a -12 if this is a +12. Something else we could have done, and I'll just show you this real quick. If we wanted to eliminate the y's, we could have multiplied the bottom equation by 7. Because when I multiply 7 times -1, that gives me a -7y. So I'd have a positive 7y on the top, and I'd have a -7y on the bottom. And then you could do it this way. You could solve for x, and then once you get x, you could plug it in and get y. So the goal with elimination is always to get coefficients that look like that are opposites, that look like this or that look like this. If you don't have them, then you have to manipulate the equations to get them.
Okay.
Okay. Great questions. This was a good session. I appreciate you guys sticking around. Okay, well, good luck on the rest of it. And like I said, I'm in office hours all day tomorrow from 10 to 3, so you can keep asking me questions, keep sending me your work, asking what you did wrong if you think you made a mistake or something like that. I can help you out.
Thank you.
Cool. No problem.
Thank
Have a
you.
great weekend, and
Thank you.
yep, I'll talk to you next weekend for the test.
Bye.
Bye.